Hey there, hope you're well. Today I want to give you a demonstration of Docker images and their layers. I had a discussion recently with someone, and layers are cached, so when you go and pull from somewhere external like Docker Hub, then the advantage is that layers are cached, and I want to show that to you today. So just to start with, I have two repos set up at Docker Hub, and one's called Layers Repo, and there's another one, Layers Repo 2. And I just want to demonstrate to you that right now they're both empty. There's nothing in them. We're going to build and push images, and I'm going to demonstrate to you the power of Docker in caching the images. So here we are in a Python directory. This is just one of my remote Ubuntu servers, and in here is a Python app and a Docker file. Let's have a quick look at the Docker file. And you can see it gets from Python 3.8 Slim base image, and you can see that we're just copying the app, and then this here is the command just to run Python and the app. And it doesn't really matter about the app. This is just nothing special. This little logging app that I made. So let me clear the screen, and I just want to show you as well. So if we look at Docker, just want to show you what's running. So I actually have a kind node running here, and I could delete that for the sake of the demo, but I'd rather not. But we can just ignore it. Now let me show you what else we've got here. So if I do a Docker system df, then this shows us that at the moment there's one image, one container, which is the kind container that's already running. So that's just a lightweight Kubernetes distribution, and a volume that is also being used by kind. And we can just ignore that for the time being. And I'll just prove it to you with the images as well. That yeah, you can see there's a kind container image that's being used and it's active. And the build cache has got nothing in it. And that's quite important. We're going to come back to that because we will be clearing this as part of the demo. So with that said, let me just clear and show you as well. I've got some scripts here to make life a little bit easier, and this will do a Docker build and a Docker tag and push and a Docker pull from remote as well. And I've got 1 and 2 to represent the two repos. So the first thing that we're going to do is we're going to do a Docker build of this app. So let me do a build 1. And you see what happens here. It's starting to go through the layers and build a local image. And it's almost done. There you go. It's getting through all the layers. And there you go. And if I do a let me just clear the screen. If I do a Docker images ls, oops, it's a Docker image ls, then you can see here that new image is now there, and it's in layers repo. This is the repo with the latest tag. So we're going to push this shortly, and if I just do also a Docker system df, you can see we now got two images. So I'm now going to push this. I think it's push, tag push. Sorry. So let me clear the screen. So tag push 1. So this is going to push it to the remote registry. And then you can see it's preparing the layers. And did you notice that there's already some layers that already exist? So I'm not 100% sure on this, and maybe there's a way to check. But what I think this is I think that this is Docker Hub somehow already having, if I just cap the Docker file again, I believe that it's already somehow got a cache for some of this. And I think it's got something to do with maybe Python or some other dependencies that it already has available. Or unless it's something that I did a while ago when I created the repo and did some work with it before, and even though I've deleted the tags, the images in there, it still somehow has something cached. So I'm not sure about that, but it doesn't really matter. I just thought I would mention that. So we have now done that, and what I want to demonstrate is if I do a docker pull now. So let me clear the screen. Sorry, let me do another tag and push. So tag and push 1. And you can see everything already exists. So when it communicated with Docker Hub, it knew already that, look, the layer is already there. There's been no changes locally, so we don't need to do anything differently. And it did that, even did a check on every single layer. So that's really good. Now, watch what happens if we delete that image. So if I go docker image ls, I'm going to delete that image. Okay, so we're going to go docker image remove, and I only need to put in a few digits because it's quite unique. AO7CF, and I need to put F for force. So it's done that. So if I now do a docker image ls, you can see that we don't have any more that image that we just built. So let me clear the screen, and if I now do a tag and push again, then it says no image. Okay, fine, because we deleted it. So let's do another build. Now that was very quick. I don't know if you noticed, but that was much quicker than last time. And the reason for that is because there's actually, if I show you again, Docker system df, then there's a build cache here. And that is layers cached locally. So we deleted the image, and it said, okay, you can go ahead and build it again. And instead of really having to build all those layers out, it knew that there was something present in the build cache. So if I now do a docker image ls, and I'm going to remove this image, and it's got the same ID, by the way, and let's do that. I think there's something wrong with my syntax there. Oh yes, it should be docker image remove, not docker remove image. Easy mistake. There we go. Docker image ls, no longer there. And I'm going to remove this build cache, which I think is using Docker Builder. So let me just look here. Docker Builder prune. That's what I need. So let me just clear the screen. Oops, clear. Docker Builder prune force. And those are the layers getting deleted, the cache layers. So if I go docker system df again, we're now back to the original state. We just have kind that's running on here and nothing else. So if I now build this again, then it should take as long as it did originally, which is about 10 seconds, I think, to build this image, or around 10 seconds. So you can see how that works. Oh, a little bit longer maybe, but yeah, it's could be variable for whatever reason. It shouldn't take too long. Almost there. Yeah, interesting is that it took a lot longer actually, and yeah, that's kind of weird. That work directory app, you can see the build time at the very top. So this is significantly longer. Honestly, I can't offer any explanation for that. I've done this so many times, and it's been nothing like that before. So if I run that again, for example, you know, super quick, obviously, because it knows that the image is already there. And let's push this again. So let me clear the screen. Tag and push. Now some of it was layer already exists, like we always had, but some of it was it does actually see this as new. If I go to Docker image ls, I believe that's a new image ID actually. So it seems that when you get rid of the local build cache, it does a whole new build. And if I scroll up and we go to the last time I removed an image, then you can see there's a different image ID. It's now 91E7. It's not A07CF. So by getting rid of the local build cache, it does seem to have more of a kind of resetting effect, let's say. So if I now, for example, let me clear the screen again. We do a tag push again, and yeah, obviously it's super quick. It says everything already exists. I think my server is just running a little bit slower at the moment compared to the beginning of the video, because even this took a few more seconds. But anyway, that's really no big deal. Now, if I do a docker pull, so I've got a script for this, pull one, and we'll see what happens here. And you can see it says image is up to date. So that's great. It recognized that. Now, how about we remove that image and see what happens? So docker image remove 91E7 force. That's a 9, not a 0. 9. And there we go. And now I do that pull again. So pull 1. And we'll see what happens. And that's interesting. You see that there? The image is gone, but when we pulled, it's smart enough not to pull, not to actually use a lot of traffic and a large payload of data. It recognized that locally these layers already exist. And in fact, it didn't pull any significant amount of anything. It just communicated with the remote site, identified in the latest tag what all the layers were, and checked locally, even though there's no image available, are there any local layers that can be used instead? And it used those instead to construct the image. So that's pretty cool. That's one of the great powers of Docker images. And it's the same way if you're running Kubernetes or Docker, underlying is the same. So that's pretty cool. Now, if we go back to here, I've got a second repo just called -2, and I'm going to actually just build exactly the same app, and we're going to see what happens. So I'm not going to change the Docker file. I'm not going to change the Python file. I'm going to build exactly the same thing. So let's see what happens when we do build 2. And you see here, that was super quick. So the beauty is that it just used the existing layers that were already there. It knew that it had all the same dependencies. This Python 3.8 Slim, and I think it even recognized that the app was identical. So super cool. Let's tag and push that. Let me clear the screen. So tag push 2. And look what it did here. This is interesting. So we got those 5 layers already existing on the remote site, and we had that even with the first one. But now for this second repo, second image, what it last time had to push, this time it didn't push. It recognized that this is an identical app, and that even though it has to supply something to the remote repo, it recognized that it was identical to number 1, and it mounted it instead. So that is super cool. If I do a tag push again, of course it should just be super quick. And it doesn't mention again this mounted part. It just says, you know, everything already exists. So that's again the power of Docker. But I really especially like this part here. I think that is super cool. So if you're an organization and all of your apps are made in Python or you know, Java or whatever it is, if your apps only differ with application code, then using Docker images is going to be super efficient, because most of your layers are already going to be cached, either cached locally or even remotely in the repo. So it's really cool. I really like the way that this works. And let's try something now. Let me clear. So if I do a pull, but for 2, and I think you already know what to expect. Yeah, it already says this, because just on on this app, it knows that there's already an image here. Now let's try something a little bit different. So if I do Docker images ls, or rather Docker image ls, and you see that the images have got the same ID. So yeah, that's really cool. So what we can do here is Docker image remove 91E7 force, and you should see now that there's only the original one there. So let me clear the screen again. Let's see what happens if we do a pull on number 2 again, and it should be similar to last time. Yep, and there you go. So all the layers are still in the build cache. So yeah, that's really what I wanted to show you, especially that the build cache will always contain some layers. But also one of the cool things is, remember when we did layers repo 2, it actually used layers that were mounted from the other app. So that's another really cool thing. So that's all I wanted to show you. I hope I'd showed you that the power of not only having those local layers, but also across different images in different repos. You could have it even not at Docker Hub, but somewhere else, that Docker is smart enough to be able to mount from other applications. So that's the power. Really cool. If you like this, please give it a like, please subscribe, and I will see you again soon. Bye bye.